Okay, I want to take a moment to go through the concepts that are presented in the collisions. We'll be doing the intro, talking about velocity and mass of objects, kind of working with Newton's second and third laws. So now mine's going to look a little different. The first one is the collisions intro. In this lab, we're going to be looking at rolling two pool balls at each other so they collide. We're going to see how the changes in the mass and the velocity of the two objects will change the collisions of them. To see how the collisions can change, you're going to be able to manipulate the initial velocity, the mass of the red ball, the mass of the green ball. You have to click yes, and it'll let you proceed to the next portion. Okay, again, yours is going to look a little different. So when you look at the pre, it'll have a pre-test. I'm not going to go through this with you because it is a pre-test. And some of these things are, well, I guess I have to. No, I don't. So we'll do the pre-test together in class. I'm not going to go through right now because I don't want to give you the key for it, but I do want to go through the lab. So there are three various labs that you're going to be doing. They shouldn't take a ton of time. Okay, so Rex is there in this one. We're going to determine how the mass of the green ball affects the final velocity of the green ball. So we can choose to either increase or decrease. In this case, I will increase the mass of the green ball because that's my goal is to determine the mass of the green ball. So if I increase the mass of the green ball, and they want to know the velocity of the green ball, where's the final velocity of the green ball? And I think because it's heavier, it's going to be harder to move, it's going to decrease. That's my belief. All right, so I'm going to run the experiment. Now, again, they give me the option of slow, fast, super fast, the mass of the ball, and then the mass of the green ball. We're going to be changing the mass of the green ball. So we'll start with a 100-gram ball. As the red ball rolls into it, we'll look at the reaction. Okay, we'll add that to our results. Change the mass of the green ball. Okay, add to results, and we'll do the 300-gram. All right, now, we've done, for our goal in this experiment, we've done all we really need to do. Come on. I have the three results. So I'm going to go ahead and finish. I'm done, because I've done what I wanted. What I did was increase the mass of the green ball, the final velocity of the green ball, and then I have to see what happened to it. Well, final velocity green ball is 1.67 and 0.50. I'm going to use all of these because they're all important. And I see that as my mass increased, the final velocity of the ball decreased. So the ball, it was harder to move because there's a greater mass, and that supported my hypothesis. Okay, so we can show the data. Write a sentence that claims what you found out about the scientific question you just learned. So what we learned was the larger the mass of the object, the harder it is to start it moving. Because you need more force. Because we didn't change our force, because the red ball didn't change. But because it was a heavier object, the larger the mass of the object, the harder it was to get it moving. It took more mass, or it didn't move as much. So in trials 1, 2, and let me just do it this way, 3, when I increased the mass green ball, the final velocity decreased, because as we saw that really trials 2 and 3, because we didn't really increase it in 1, it was just there. So in trials 2 and 3, when you increase the mass of the green ball, the final velocity decreased. I should probably spell that right. And as always, my reasoning for this is my data supports my claim. Okay, and that is that portion. Okay, the other test, we could look at the initial velocity of the red ball and how it affects the final momentum to the right. Okay, so let's go through there. Okay, so we're going to increase the initial velocity of the red ball. And we're going to say because it's going faster, it's going to the total momentum to the right. Now, if I know law of conservation of momentum, it really shouldn't change. Let's find out. I'm going to say it stays the same. Let's find out. All right, so I have super fast, slow, fast, and super fast. We're going to go run trial fast or slow. And there you go. Add to our results. Go fast. Add to our results. Super fast. Oh, it's because they have momentum to begin with. That's why. So what I see is, no, I was wrong because I thought wrong. As I increase the speed of the initial momentum of the red ball, again, I can't lose momentum, so the momentum increased. And I can have that's just another trial. I would do that one. All right, so finish collecting data. Now, when I increase the initial velocity of the red ball, the total final momentum to the right actually increased. This does not support my hypothesis because my hypothesis was wrong. That's okay. Now I just want to use the first three because the last one was an error. What did I find out? I found out as we increased the initial of the velocity of the red ball, the total final momentum increased. Okay, we can see if we show our data that as we increased in trials 2 and 3, when I increased initial velocity of the red ball, the total final momentum did increase. Yes, I know it's the exact same thing. That's why we say my data supports my claim. Now that's probably all I'm going to do. I don't think I'm going to do the third part of it because 2 is enough. I think the third part just goes over the exact same concept. Oops. It's around the mass of the red ball. So we may do all 3, and then there's a post test. So those are the first 2 labs that we'll be doing. Hopefully that helps. If we do the third one, I will add a third post later on.